Hello and welcome to this LangChain tutorial. So now when we have gone through all the building blocks of RAG application, let's dive into creating a simple RAG application. But first some theory about RAG. So first thing is, what is RAG? So Retrieval Augmented Generation RAG is an AI framework actually that improves the accuracy and relevance of large language model, right? So what you get from LLM, that accuracy and relevance of that output is enhanced by this RAG application. So with the RAG application, you fetch data actually from external trusted knowledge bases and send that data and user's query to the LLM to generate a response. So what exactly RAG does? It augments the generating abilities of LLM by providing external data, and it also solves LLM limitations such as hallucination and outdated data. So it provides context aware information without requiring any model retraining. So you don't have to train your LLM with new documents and new data. You augment that, right? So first thing, one thing here is, what exactly is this LLM hallucination? So when you ask something outside LLM's training data or context, right? So LLM will still try to produce a fluent, coherent answer because their objective is to predict the next most likely word, not to verify truth. So even if you ask something which is not in the training data of LLM, it will still try to answer that. Generally, that answer will be wrong, right? But if you augment that generative capability of LLM by providing it some content of your own and ask it to use that content to answer the query, then you will get a right answer. So that's what RAG does. So prerequisites of creating this application is, so if you want to create a RAG application using LangChain framework, then these are the prerequisites. You should have knowledge about document loaders, text splitters, embeddings, vector stores, and retrievers. So if you have not gone through chapters where these topics are discussed, it is advisable to first cover those topics and then come here. Then it will make more sense to you. Now, what are the steps we are going to take to create the RAG application? So first thing, as we have already done in previous chapters, you have to load the documents, which are going to be PDF in this example. And for that, you will use the document loader. So in this example, we are going to use directory loader to load all the PDFs from a specific directory. Then using text splitters, you will create smaller chunks of the loaded document. That is the second step. Then as a third step, you will store all these chunks as embeddings in a vector store. And we are going to use Chroma vector store. That also we have covered, where I told you about Chroma and Pinecone. So we are going to use Chroma in this example. Then you have to do a search, similarity search, to get the relevant chunks from the vector store based on the user's query. Then the content you get, right, relevant chunks, that plus the user query, that you will send to the LLM to get answer. So that answer will be based on your knowledge documents, correct? So that is the objective of creating this RAG application. So this flow is also shown as an image here. So you have the first step is to load PDF documents, then you split it into chunks, then you create embeddings, then you do similarity search, and then you generate the answer. So these are the 5 steps you have to take. All right. So to create it, first 2 things we have already done. All right. So I created a new folder, L10 rag. Here I have already copied these 2 files which we have already created to do all the steps of loading the document, splitting, creating embeddings, and storing it in vector store. Right. So there is a util.py file where we have functions, utility functions to load document using directory loader, split it using recursive character text splitter, Then we also get an instance of embedding model because your Chroma store will need it. Then we have a separate file, chroma db underscore util.py, where we keep all the vector store related code. So we have a function get chroma store, where we create an instance of chroma by passing it a table name, collection name, embedding function, which we get by calling that get embedding model, because query which you send, right, that also has to be converted into dense vector, and directory where all this will happen, this table and all will be, and all your data will be stored, that directory you give. Then you load data. So there is a function load data where you actually load data by calling all the functions load document from util.py to load the document. Then you create splits, then you add these documents to the vector store. And this, as I've done in previous examples already, so you have to run this file so that this all is already done. You don't do with each query, correct? That won't make much sense. So you should run it already so you have data in your vector store. Now one more function I'll add here, because till now what we were doing in vector store and retriever, we were creating a file where we were doing a search. Now I'll add that function also here to search in the vector store. So let's name it search underscore data. So it will get a query and it has to do a search based on that query. So here also first thing I'll call the vector store get chroma store. Then using this instance, I can do a similarity search, where I can pass this query itself as query and how many documents I need. So I'll keep it as 3. So I'll get the 3 relevant documents, right? So similarity search, that will be my result, which I can return. So this search is also done here itself. Now I can create a new file where we'll join everything. When we get a user query, we'll come here to do this search and other steps. So let's name it simple rag.py. That's where we'll join everything. So these are the imports for this. Again, I'm going to use NVIDIA as an inference provider and the model also. Let me get my prompt also. So this will be the prompt. So here again, if you see, we are making it very explicit that it has to use the context, use that context which we will send to answer the given question. If the retrieved context does not contain relevant information to answer the query, say that you don't know the answer. Don't try to make up an answer. So we are not giving LLM any scope to hallucinate. We are asking it explicitly to give an answer based on the given context only. Right, so we have this. Then let me get two more things, which are the model which I'm going to use. So I'm going to use model also from NVIDIA, which is Nemotron 3, and some temperature and parser also. Now first thing, I'll create a chat prompt template dot from underscore messages, where I can pass as a list system. There I'll pass this system message, and as a human message I need to provide it the context, and also the query. So both will go to the LLM. So I need to provide the context as well as the query. So that will be my template. I already have model parser and this prompt is also there now. I have to give it a instance prompt. Now I can create a function where I'll actually call this. So let's name it generate response, where I'll get the query from my UI. So we'll create a UI also using Streamlit. We'll create a chatbot. From there, we'll send the query so that will be received here. Now that query we have to send to the search data that I've already imported from chroma_db underscore util, which is this file. So search data, there I'll pass this query and it will give me some results. That will be the documents which we get from similarity search. Now, one thing is, when we are sending to LLM, we won't send it as it is. We'll extract the content out of these results, and three results we'll get, right? K equal to 3 we have given. So we should append all of them and send that to the LLM as a context. For that, let's create another function where I get these results and that can return them as and slash n dot join. So I'll join them and send them as a joint result, which you can say is the context. I can use list comprehension doc dot page underscore content for doc in results. So get these document, from that retrieve the page content and join all of them. Then I can call this function here, append underscore result, or let's call it append results. Here I'll pass all the results and I'll get my context or chunks, whatever you call it. Okay, so now I'll have my context. Then I can create my chain, which will be prompt model and parser. So we can invoke that chain. There I'll send as a directory. What I need to send is context, which is context only, what I've created here. Second thing I need to send is in prompt, I have named it query, right? So I need to send this query, which is the query I get here, right? So now I can invoke it, which will give me the response, and I need to return that response to my chatbot. So that is all I need in this file, correct? Let us verify once. So what we need is all the imports. Then I load .env also, so we get our NVIDIA API key. Then prompt is also there. I mean, system message is also there. And model parser. Then we create a prompt from messages, system, human, and generate response function is there, where we get the query, all the search data, result. Then we append results. For that I have a function here that I need to send as context and query and return response. Okay, so looks fine. Now we can create another file to create our UI. So to create the UI using Streamlit, we'll create a new file. Let's name it simple rag UI.py. Alright, so here we'll create our UI which needs Streamlit and also our function, this function as import. Right. So first thing we have to give some page config and titles. So that will go to the window, your tab in the browser window. There, what you want to show, that you can give here. So page underscore title equal to, let's say, rag chatbot. Layout I want as centered, and title. That will be the title of my application. So name it medical. So I'm still using the same PDF, right, where I have some data about medical insurance policy. So I'm giving title as medical insurance chatbot. So in Windows, I can also give some emoji, right? So these are some settings before that. Now, as in previous videos where we created a chatbot, I showed you that you need to retain the chat history for Streamlit, because whenever you create a new query or ask a new query, Streamlit code will start from top to bottom. So everything it will run. So you should retain your chat history and print it, everything, whatever you have. Otherwise, everything will be gone. So for that, what you'll do first, you'll check. So if I name it chat underscore history, if chat underscore history not in the session state of Streamlit, okay. So you'll check first if chat history not in the session state, then you'll create a new chat history as a empty list. Then you need to go through this list for message in, so that you can print all the previous messages. So that's what you'll do in the beginning for message in this chat history. So with that, I'll do the grouping also with st dot chat underscore message. So Streamlit has some component related to chat, your chat message, chat input. So it gives you UI relevant to chatbot kind of UI you'll get, right? So you should use these components. So chat message is there. Using that, what I can do is I can group. So what I'll do is message, each message which, or you can say each query which you type, that will be added as a dictionary which will have two key value pair. One is role, one is actual message, because you will get answer also, right, from LLM. So that you will give as AI or assistant some role, and what you are asking is user or human role. Or you can say each message will add as a dictionary with two key value pairs, role and actual content. And with this with will help you in grouping those roles. So with that, I'll add the message as a markdown. So dot markdown. What I'll add is, from message I'll get the content. So this way I can get all my previous messages. Now I'll get the user input. User input equal to st dot. So we have another component st dot input. Using that, enter your query. So I can ask the query, right? Chat input, enter your query. Now you can verify actually if user underscore input is there. Then what you'll do, again you have to go through all these steps for adding it into chat history. First thing, so st.session.chat underscore history. So we'll append to it this message. So how will you append it? The role will be user in this case because this is the query from user, and content is this user input. So that's how you'll add it in chat history. That is one thing you have to do, correct? So chat history append with role and user, as I was telling, that's how then I can extract because I've added it as a dictionary here. Then this also I have to show to the user. So for that, with st dot chat underscore message. Role is, in this case it is user, so I can directly say user. Then st dot mark down. There I can give this user input. So that is what you will do for user query. Now this is for the UI part, but I have to send it also. So response I'll get back. Now I can call this function generate underscore response. There also what I'll send is this user input. So my query, it will go there, then it will go through the whole flow of similarity search, appending them as a result, sending it to the LLM query, and those context means all the content chunks, then it will get a response. Now I have to send the display that response also. So I have to do the same thing again for the response part. Role, let's say it is assistant. Content this time will be this response. So I can hard code this part, and this will be response. All right, so that's how I can show it here in the UI. I can show it st.session state chat history append. So assistant and response, with this time assistant role will be, and with that I can send a response. Or if you want to make it that it is from chatbot, I can do something like this also. Response, and what I do is chatbot response and this response. So chatbot response, what I get as response. If you want, you can also give a else part where you can just say st dot warning. Please enter your query. Okay, so that is about creating the UI part also. So we are done with the coding of our RAG, where we have the RAG flow and a UI also, simple UI, from where we can actually ask the question and get the response. So let's try to run it now and see if it works properly. All right, so to run it, one thing is just to tell you guys that what I'm using is Olama and embeddings here. So I have a local setup also. So I have started my Olama server that will act as the embeddings, because as I've already told, your query also will be converted to a dense vector, and in Chroma instance you give this embedding that when it get some query a similarity search, that query also it has to convert to embedding using the same embedding using which you have put it there, your code chunks. So with that, let's try to run it. My file name is the simple reg UI. So streamlit run, you have to do this since we are running the streamlit code. So dot slash, where is it? L10. Simple reg UI dot py. That will automatically open a browser, or it will give you URL also. You can open yourself. And if everything, no, everything is not fine, we have an error. Okay, I missed some. Here I missed colon. Let me check other places also. Okay, so we got our UI where I can ask a question now. So let me ask, what are the coverage rules for newborn baby? Right, so this is my question. Okay, so this is the response I got from Chatbot. According to the policy wording, it's not automatically covered, and some rules it has given. So looks like it is able to go through all that flow similarity search. It has given me that three chunks, right, which are then appended into a single context which is sent to the LLM. And while appending, you take the content part only, because that will have other data also, metadata and other thing which we have seen in document loader chapter. So that's the response, right? Let me have something else also. What are the rules for pre-existing diseases? What are the coverage rules for pre-existing diseases? This is my second question. Okay, so just to inform that when I was trying to ask another query, it was going through that chat history. There I had one error in this markdown part. That spelling was not correct, so I have fixed that. Now I have to go through again through my queries. So what are the coverage rules for newborn baby? So let's see if we get the same error or not. So I'm going through the same sequence. First one thing, so the it is giving something about that. Then I was asking what are the coverage rules for pre-existing diseases. Okay, so it is giving me some not covered something it is giving. So looks like it is able to answer that also. One thing which is it is not able to answer is this. Yes, so if you see, it is not trying to fabricate an answer now. It is giving me proper response, that it is not able to proper response here means that it is not able to get it from the document what I'm asking. So it is not fabricating any answer. It is just telling me that provided context does not contain any information about co-payment rule. So it is not able to give an answer. All right, so this is how you can create a simple drag application But there are other things. We don't have a conversation history. We have only history for Streamlit, which is used only for this part. Showing it here, it is not the conversation history. So all that we'll do in the upcoming videos. We'll extend this RAG application to add some more functionality to it. But first, this simple RAG application to give you a flavor of how you can create a RAG application. Thanks for watching the video. Please don't forget to like and subscribe.